Welcome to our channel Higher Mathematics. In this video lecture, I am going to discuss next PYQ of real analysis asked in CSIR November 2020. So our question is, let f be a non-constant polynomial of degree k and let g from R to R be a bounded continuous function. Which of the following statement is necessarily true? So here f is a non-constant polynomial of degree k. First we have to take one polynomial f and one bounded continuous function which is g. So we will take this two and discuss the option. First option said there always exists x0 belongs to R such that fx0 is equals to gx0. So if we take k is equals to 2, that is polynomial of degree 2 which is fx, and let gx is equals to -1. Okay, then this function is what? Bounded, continuous, as every constant function is bounded and continuous also. So if we take x0 is equals to -1, okay, now we'll put f of -1 which is equals to minus of 1 upon x square, that is equals to 1, and g of -1 is -1 only. So we see f of -1 is equals to 1 and g of -1 is equals to -1, which implies what? F of -1 is not equals to g of -1. So first option is false. Here always given, so this is not true. We have one option which contradicts this. Okay, next, there is x0 belongs to R such that fx0 is equals to gx0 if k is even. So if k is even, same example for this question also, k is even, let k is equals to 2, and for the same we say that there no such k which is even for which this condition is true. So this also an option is also wrong. Now we will discuss C option. There is no x0 belongs to R such that fx0 belongs to R. So here no x0 is given. So if we take k is equals to 1, that is k is equals to 1, then polynomial fx is equals to x, and same gx is equals to -1 or gx is equals to 1. If we take any of this, then x0 is equals to 1, for x0 is equals to 1, f of 1 is equals to 1, and g of 1 is equals to, if we take this one, it is 1. Or if x0 is equals to -1, then f of -1 is equals to 1 and g of -1 is equals to also -1. So we have 1. So this option is true and this option is false. So this is the solution of this question. That is, if k is odd, then we can find there exists one x0, this belongs to R such that this condition is true. So this function, for this function, this condition can be true. So this is the solution of this question. If you like this video, hit the like button, and for more such video you can subscribe my channel. Thank you for watching.